Okay. Okay, Mahdi, we have done that. Can you hear me, Mahdi? Can you see the paper?
Still no.
Still no. Now?
Now, okay.
Fine, okay, right. Yesterday we have done the question number 26, the Born-Haber cycle. Okay, we completed that. Okay, I asked you all to do the question. Didn't I send? I sent the question, right? No.
No, madam.
Oh, I'm really sorry. Let's we try that question and finish it off, right? I'll send you now. And I sent the year of the paper. At least you would have been done. Okay, I have sent the question, right? I'll give you 5 minutes is enough. Just go through the question and let me start. Go through the question and try it since we'll do the question. So can I see the question? Question I have sent you. Yes, Mahdi?
Madam, you're lagging.
I don't know, today connection has this. Still upset? Can you hear me?
Yes.
Fine. I have sent the question, right? You can try it now. Just try the question. We'll do and finish it and move on to the next question. Now it's 21. We'll do the question at 8:30. Please try the question. So the question is clearly given, right? I just write what is the question is given is calculate the enthalpy change for the reaction. So they didn't mention that is a Born-Haber cycle, but you should able to understand what they are asking here. You have to find the enthalpy change of the reaction is given magnesium solid reacting with oxygen gas and giving off magnesium oxide. That is a solid. They have balanced the equation. This is two, right? At 25 degrees Celsius using the thermochemical data given below. So by looking this, you can understand the data also given down is fully it's speaking about what? The Born-Haber cycle. So kind of the formation of magnesium oxide. They can't write as a 2 here if they said this is as a formation of the magnesium oxide. Why they didn't say this is as a formation of enthalpy change of formation of the magnesium oxide? They couldn't say like that. The reason is your product always should be 1 mole. Here that is not a 1 mole. That's why they didn't say this is the formation reaction of the magnesium oxide. But it seems to be like a formation of the magnesium oxide. Rather than asking like that, they ask you to find the change of the data enthalpy of this reaction you have to find. So let's try the question. The data is also given. Now 8:24. We start around is 8:30 or 32, right? Just try the question now. Yes, Mahdi. Finish. Yeah, can you hear me?
Yes, madam.
Finish. Still doing or
Yes.
you got stuck? Nothing to stuck here. Still doing. Yes? You need time or you couldn't do. I just needed to one answer.
I did it.
Okay. Mm. Okay, let's do the question. It's okay. Fine. You found the answer? Can you hear me? Adi. Hello? Can you hear me? Okay, fine. I'll do the question. Okay. So you have to find what magnesium solid plus O2 gas to find the reaction of this H2O solid. All are two. So your first step is the data are given. The bond dissociation enthalpy of O2, first affinity of oxygen, second electron affinity, enthalpy of a sublimation, first ionization. There is a problem in connection. Okay, so magnesium solid react with the oxygen, giving birth to magnesium oxide. Sorry, this is 2, this is 2. So what should be the data? So, okay, according to the data, let's see do. The first thing is sublimation will turn into what the, sorry, solid should turn into the gas. So it's a Mg gas. And here 2 mole, therefore that should be 2. So what is the value for this? The sublimation. The sublimation is given 148, right? And you just check here, you have the 2 mg, therefore you have to multiply this value into 2. Next, this mg should convert into what? The first electron affinity mg plus, sorry, electron first ionization energy. Here also 2. Therefore, you have to multiply. The first ionization energy is 2 into 738 kilojoule mole minus. Next, the Mg, Y should be converted into Mg2 plus second electron negativity. So again, you have to multiply this is into 2 second electron affinity. Sorry, second ionization energy kilojoule mole minus. This is for what? The conversion of the Mg plus. Next we go for the oxygen. The first is oxygen is a molecule. You have to break into what? Yes, oxygen molecule. So here you can see oxygen is converted into oxygen gas. So this is bond dissociation energy, that is what? 498 kilojoule mole. Right? Then this bond dissociation energy, okay, the oxygen should convert to O minus gas. Here also 2. So that is the electron affinity of 2 into minus 114. Okay. And the oxygen second electron affinity O2 minus. 2 into your second unit can assign to 798 kilojoule minus 1. And actually they have given what the magnesium oxide, right? The formation of what? The lattice enthalpy change. So where Mg2 plus and 2O minus, O2 minus react together. I have missed a 2-way. And which will give so that is what here you have. They have given the 1 MgO, but you have to find the 2 MgO lattice formation. So that value is 2 into minus 3091 kilojoule minus 1. So you have to find the delta H theta for this reaction. So according to the Hess law, this is as a root 1 R1 is equals to this all the root 2 R2. So let's rewrite the value. The delta H theta is equals to 2 into 148 kilojoule mole minus 1, 2 into 738 kilojoule mole minus 1, 2 into 140 1451 kilojoule mole minus 1, and this is 498 kilojoule mole minus 1, 2 into minus 149 kilojoule mole minus 1, plus 2 into 798 kilojoule mole minus 1, plus 2 into 3791 kilojoule. So you can find the value. The value is minus 1124 kilojoule mole minus. Yes, what happened? Okay, I have done the question. You are not there and I just start to do the question. At least can upload the video, right? So I have done the question. Have you found the answer? Is 1112 value. 1112 kilojoule. So this is very important and you should be noticed. As it is what for the 2 mole of the Mg. Your reaction, your data is given for 1 mole, so you have to multiply all into 2. This is a 1 matter. You should notice. Here oxygen is there. Dissociation is 1, that is correct. But then after that it's forming the 2 mole of the oxygen, therefore your value, all values should be multiplied. And finally the 2 Mg plus and 2 O2 minus will give the 2 mole of the Mg oxide. So the formation of the lattice is, again you have to multiply by 2. So this is the very important when you are doing that. You have to notice it. Right? Okay. So let's move on to the MCQ now. Okay, let's do this question. Question number 27. Activation energy of the elementary reaction. Okay, that is a one-step reaction. That is A gas, B gas will give the C gas is the activation energy is given. This reaction is catalyzed by the M, metal M, right? The energy diagram of the catalyst reaction given below. Okay. Actually, they have given the activation energy. So, what is mean by the activation energy? Yes. The minimum energy required to complete the reaction, that is what we are telling the activation energy. When A gas is reacted with the B gas, it's giving what? Your C gas, okay? This is your reactant, this is your product. So, if it is the activation energy, should be that. So, this would be, right? You should be able to understand this would be what? Okay. Right, just this like that. Okay, so this is I'm talking about without catalyst. Without catalyst. So when you use the catalyst, you can see it's a three transition, right? And they are asking which of the following always correct with regard to this reaction, which should be correct. So they are telling is, we said this is your activation energy EA. The EA always. Okay, just look at here. The EA is always higher than these values, right? We are not talking this is as equal. And this is what the transition of the delta H1. So what should be a UEA? It's always higher than this this is what we have used with metal. So when you use the metal, what it will do is it will reduce the activation energy. Activation is a kind of the barrier to reach a product, reactant to go. So what it will do is when you use the catalyst, it will reduce the activation energy and it will probably lead to your product. It will faster your reaction. That is what we are using the catalyst. So they said according to your first statement, the activation energy is less than the E1 value. That is really false. The statement is clearly not true. Why? We said your activation energy, that is we are speaking what without the catalyst. So if they said the EA is higher than the E1, that statement definitely correct. But when you say like this, EA is less than the E1, so that is wrong. And look at here, the EA is equals to, they are adding this one E1, H1, sorry, E1, E2, E3 minus H1. So actually you just check it, right? When the activation energy, we said it's higher than these three values. If they said like this, the EA is higher than, the word is very important, E1 plus E2 plus E3. Yes, all activation, all different transition activation energy should be subtracted by this enthalpy change to find that okay. So if they said like this is correct. When you said like the equal, that question also right. And go for next. The EA is, again what I said is the EA is less than the E1, EA is less than the E2, EA is less than. Again these all three are different. Sorry, referring that statement is wrong. I said if it is the other way, right? If they said like this, the EA is higher than the E1. The EA is higher than the E2 and the EA is higher than the E3. Then this statement would be correct. Now, what is because of this? The statement is wrong. We'll go for the final. Okay, they said, okay, your fourth one. The EA is always higher than the E1 plus E2. The EA is always higher than the E1 plus E2. What should be the answer? Is it correct? Until now, they said equal, that is wrong. They said what? Less than the other value, that is also wrong. And finally, they are telling is the EA is higher than the E1 plus E2. Is it correct? Which should be always correct. Yes, the EA value is higher than the E1 plus E2. What about the E3 value? Did they mention? Did they mention about what? When you say the E1 plus E2, yes, the EA is higher than E1 plus E2. So they mention only these two. Okay, they converted the all transition reaction. What about the E3 and this delta minus? So at least they have to mention this is delta. So therefore, let's do that. And look at your answer is fifth one. Why the EA is higher than the delta H1 plus E2. That is correct. Why you can see is I just drew. If you draw the activation curve like this, it's almost that activation energy which is equals to delta H1 plus E2. It's always is less than the activation energy. So here you no need to mention the E1 and E3. Why? This data is hovering up to what? Your delta H1 plus E3 plus E1. So therefore your answer is 6. Okay. Again I'm just recalling. Look at your question. Right. We have another color. Just keep look at very clearly. The activation energy without metal is always higher than this transition, the original activation energy for the reaction. So this is without catalyst, therefore higher than. So the less than word is what? It's simply given the 1 and 2 is wrong. 1 and 3 is wrong. And it's also I said it's always higher than. So equal also will lead to 2 also. Now we have to say higher than. So either 4 or 5 should be the answer. Again, I'm just checking the E1 and E2 they mentioned, but they didn't mention about what the E3 and the delta H1. So this is always correct. Therefore, this is also wrong. Finally, your 5-1 or the fifth answer is correct. Why I said when you combine the delta H1 E2, that activation energy with the metal, right, is completing when you compare with others. So therefore, this fifth answer is correct. And let me do the next question. Did you understand? Is it clear? The next question.
Yes, madam.
The question number 30, 30, okay? Okay, again, just go through this question. I'll be back now, right? Okay, fine. So the question is, the two ideal gases that do not react with each other and separated by a wall and kept in a rigid container. This system is maintained at constant temperature and pressure. Which of the following correctly describes the change in Gibbs energy, enthalpy, entropy of the system respectively when the valve is open? The question is clearly given. That is what is two are the ideal gas. So we know ideal gases never react together, right? Okay. So even though you mix it. So earlier what they have done, they have used the two different rigid containers having the different ideal gas A, B. And that has maintained at the constant temperature and the pressure, right? So when this valve connected, open, they mix together. They are asking what should be the Gibbs free energy, enthalpy, entropy. So earlier it was maintained separately. Once you connect, definitely the Gibbs free energy will decrease. Why? Earlier it's maintained once the reaction happens, right? Okay. So there should be what it's a ideal gas. You should be definitely no any chemical reaction. There is no attraction, the bond formation. Nothing is there. But once its reactions happen, it's mixed together, the pressure able to decrease and your randomness able to increase. So you use delta G is equals to delta H minus 2 into delta S. So the randomness is increasing. The temperature, even the temperature is maintained also. What is happening? This value, the minus value is increasing. This delta value is decreasing. So your Gibbs free energy should be decreased. Therefore, you can omit the number 5. So it should be 1, 3, 2, 4. And check your enthalpy. So what is happening? The enthalpy, there is no any attraction between the ideal gas. I said the ideal gas never go for the chemical reaction. Ideal gas, no attraction. So once you mix, they are able to form the bond and this mass able to increase. Therefore, there is no possibility like that. Therefore, we are telling your enthalpy is unchanged. And again, yes, it's simply all others are decrease and increase. Here we are telling unchanged. Your answer should be 3. And I already said the entropy, once the molecule mix together, ideal gas is none. Yes, the randomness will increase. Why they able to collide each other? The elasticity is higher than your real gases. Why there is no attraction? That's why we said your delta enthalpy doesn't change. So that should be increased. So even though if you check the entropy, you can omit 1 only. So you have to check the answer either. So one of these 3, 2, 4 and decrease increase is wrong. If you know the definitely answer, then only you can find your answer is right. Okay. Did you understand? Is it clear? Okay.
Yes, madam.
So next we go the question number 33. Okay, your question is, if an endothermic reaction occurs spontaneously at constant temperature and the pressure, then what should be your enthalpy and the entropy regarding to the reaction? And what should be the answer? Any guess?
Enthalpy will increase.
Give me a second. Enthalpy is increased. Why? What is the reason? What is the reason your enthalpy is increasing? So this is what, okay, you have said is right, but you were able to say the reason. Only the enthalpy is increasing. If there is answer, enthalpy is increasing. Yes. Only that is the answer. Here, this is what the question number about 31 to 50, sorry, 40. That question you have to find the correct answer, and the combination of the answer will be your, according to that you have to select the answer, right? So okay, let's see. In a the endothermic reaction occurs spontaneously at the constant temperature and pressure. When you say the spontaneous, definitely yes. That is it. Definitely the delta G value is less than 0. Why? If it is spontaneous, that should be minus value. So to maintain, you should be very careful about that. That should be the negative value. So you can use the delta G is equal to delta H minus T delta H. This is constant. Temperature is constant to the side. And delta G should be negative, I already said. And what should be the delta H? According to you, you said the enthalpy will be increased. Yes, that is a positive charge. Why? It's clearly said it's an endothermic reaction. Endothermic reaction means what? It's absorbing energy of heat. Energy of heat. When you absorb the energy of heat, the value of the enthalpy is increasing always. The endothermic will give the positive charge. Your answer is right. The enthalpy of the system increases. Right. And that is very definitely is important. Your temperature is constant. And I said there should be negative value. If it is positive, again this is a minus. Your temperature is a constant. And if you want to maintain the negative value, definitely your entropy also should be positive value. Why? This is also positive. As the positive value is increasing than your enthalpy, then only you can maintain the negative value. Did you understand this is what I said? Again, I'm just telling you, right? When you said the reaction is a spontaneous, that should be the delta G is less than 0, so negative value. This reaction, when you speak about the spontaneity reaction, we always use this reaction. So this is the negative value, right? And I said this is what the endothermic reaction definitely is absorbing the energy, right? Once you absorb the energy, you'll be very, very clear, right? The enthalpy change is increasing, so that is positive. That statement also. And we said it's a constant temperature, so your temperature doesn't change. And the delta entropy. So entropy of the system does not change is wrong. If you keep this is also constant, the positivity is increasing, and what will be happen? Your delta G become positive. So if it is positive, your delta G is positive now. That is not spontaneous reaction, so this answer is wrong. Enthalpy of the system is decreasing, that is wrong. Why we said that is wrong? Yes, it's absorbing the energy, the endothermic system. And the entropy of the system is increasing, and you have to check whether this entropy of the system is increases. Yes, that should be increased. Why? As we said, this is a minus, your temperature is a constant. We know the enthalpy is a positive. We need to maintain if the Gibbs free energy should be negative. So this entropy should be higher positive than your enthalpy. then only you can maintain the negative charge. So your answer B is correct. So this is answer combination A and B. I think the AB combination is, sorry, BC, sorry. Your combination is BC. So your answer is C. Are you clear? Is it clear? Yes, Mahavi.
Yes, madam.
Question number 42. We have question number 42, 44, and 42. 42 and 44. Let's redo that question, right? And you have to go for the about the 41 to 50 question, the true false question. If you both, the first statement is true, the second statement also true, right? Which is explained the first statement. We have to read that careful. Should be very careful. If both are true but does not explain the second statement about the first statement, that is what the one is true false, another one is false true, false, that you can be understood. The thing is, the first and two is a little bit complicated. You are able to understand. If your second statement is explaining the first statement answer, then only one. If not, your answer is two. Right. Your question number 42. Can you try this question? Question. Yes. The question number 2. At a given temperature, the spontaneity of the reaction between N2H2 to give the NH3 drops with increasing the temperature. Again and again, they are talking about what? That spontaneity of the reaction. What is the equation? Yes. Delta G is equals to delta H minus T delta S. Okay, let's we do one thing. I'll go to the what is that whiteboard of sharing and go. Your question is 42. At a given temperature, the spontaneity of the reaction between, right? I'm talking. The spontaneity of this reaction. What should be the reaction? N is reacting with H2 gas, right? And which will give the NH3 gas. So this is 2, this is 3, this is your reaction. So they are telling the spontaneity of the reaction between the N2H2 to give the NH3 drops with increasing the temperature. So again, I'm just talking about the delta G is equals to delta H minus T delta S. Right. So when you say this is spontaneity, it should be negative value. That statement is correct. So can you see here? They are telling us that quantity of reaction H2. Yeah. Sorry, at a given pressure, the spontaneity of the reaction, the spontaneous is dropping, increasing the temperature. Okay, by increasing the temperature. Yes. So what you want to do is, first thing is, right, you should be able to find that mole ratio. What is the moles of your product? What is the moles of the reactant? Yeah, your moles of the product is 4. 4. Why? Here 1 into 3H2 4. Your moles of the reactant is 2. So that is very important, right? According to the equation, the 4 moles of the reactant gives the 2 moles of product when the reaction will happen. Right. So you should be able to understand the entropy change has negative value. Why this reaction is exothermic? Also negative value. So how can you say? Actually, this is what you can speak about the entropy. How? The delta S theta for the reaction. Delta S S theta product minus delta S theta reaction. So the mass of the product is less than the reaction. So therefore your delta S value will be minus negative. The same way, if you apply for what? The enthalpy also. Okay. So when you use that enthalpy change also, the different equation, right? The enthalpy also, theta reaction is delta H theta product minus delta H theta reaction. So therefore, delta H theta product, again if you go for the mole 2 minus 4, so that is also negative value. Right? So according to this, we can conclude your enthalpy is negative minus your temperature and your, yes, entropy also negative. So therefore, what should be the delta G? Yes, this is negative, negative into negative, positive T. As the temperature is increasing, what is happening? This is always negative value. The value is increasing, therefore your delta G becomes more negative. So more negative means what, guys? Yes, this reaction as the temperature is increases, it reaches to the more spontaneity. If it is spontaneity means what? It should be more negative. Therefore, as your this value, your enthalpy, yes, your entropy become more negative by increasing the temperature. Your total that system also become more negative, right? Therefore, this reaction, the spontaneity also increases. Did you understand? The first statement is correct. Right? Are you clear? Are you clear? Long. Entropy change of the reaction between the N2 and H2 to give the NH2 is negative. Yes, because of this entropy change, we said, right? Which is become the more negative. That's why the spontaneity of the reaction also increasing. Yeah, your second statement also true, right? And which is explains your first statement. Your answer is one. Are you clear? Are you clear?
Yes, maybe.
And wait, I'll just show you. Again, look at this question now. There is no space left, I know. Okay, so look at here. The question is clearly given. At a given pressure, the spontaneity of the reaction N2H2 is Q drops with increasing the temperature. Right? So as your temperature is increasing, the spontaneity of the reaction also become the less negative. Why? As we said, your delta H is also negative, so you can say that it's exothermic. And the temperature increasing, your delta S is negative value. Right? Your delta is also negative. As the negativity is increasing, with increasing, so your positive value, this value, the negative value, which more increase than your delta is. So if it is the negative value is increasing, your delta G is negative value also. The amount of increasing negative value also will drop. Therefore, your spontaneity of the reaction also will lead to the drop of the temperature. So therefore, your first answer is correct. And they say because of the entropy change which is become negative, that is the major reason why the delta G, the spontaneity of the reaction also going down with increasing the temperature. Therefore, that statement also. So your answer is this is true, this is true. No answer is not. Okay. And you have the question number 44. Okay, we'll do this question tomorrow. Right? So
Yeah, we'll do that tomorrow. Yes.
yeah, but now we have other class also. Okay, right. See you tomorrow. You can leave. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, madam. Assalamu alaikum.
Take care.